look at the reaction of group 1 metals with water. So let's think first of all about what happens if we react lithium with water. So this diagram here represents a trough with some water in it, and we're going to think about what happens if I take a piece of lithium and drop that into the water trough. Well, the first thing to note is that the lithium would float on water, and the reason it floats on water is because lithium metal is less dense than water. The second thing to note is that we would get around the lithium some bubbles, and that's because the lithium reacts with water and produces hydrogen gas. So in this case, I'm just giving its symbol, which is H2. It would also move around on the water surface because of the bubbles being produced. If we were, once this reaction was over, to take some universal indicator, so here's a bottle of universal indicator, and add a few drops of universal indicator into the water trough, then the water trough, or the universal indicator in the water trough, would turn purple. And that's because lithium hydroxide, and I'll write the name under there, lithium hydroxide is produced, and lithium hydroxide is an alkali. So we also need to be able to think about writing word and symbol equations for this reaction. So lithium reacts with water to produce lithium hydroxide and hydrogen gas. So if we were going to look at doing a symbol equation for this, we'd have Li for the lithium there and H2O for the water, and that would go to produce lithium hydroxide and hydrogen. We would also need to balance this equation by putting a 2 in front of each of these, and we also might want to think about putting state symbols here. So I've got an S for lithium solid, an L here for liquid water, an AQ here, which stands for aqueous, which means that the lithium hydroxide is dissolved in water, and then a G for the H2, the hydrogen, to show that a gas is produced. So if we just quickly review what we've had a look at here, then in terms of our reaction, we've got lithium being put into a water trough. We would see a number of things. The lithium floats on water because it's less dense than water. We'd see bubbles produced around the lithium because hydrogen is being produced, hydrogen gas, and obviously the lithium would also move around the water. And then if we were to add a universal indicator, so a solution that changes colour depending on whether something is acid or alkali or its pH, into the water trough, we would see that that universal indicator turned purple because the lithium hydroxide produced is an alkali. Let's have a think about how these reactions would be similar and how they would be different for the reaction with sodium and the reaction with potassium and water. So again, if we added sodium, so this is a piece of sodium to the water, the sodium again would float because it's less dense than water. Again, we would see bubbles and it would move around the surface because of the bubbles being produced. And in fact, because sodium is more reactive than lithium, it would move around the surface faster. If we were to do the same thing with potassium here, so here's potassium, this time the potassium the gas produced, the hydrogen produced, would ignite, it would catch fire. So again, potassium would float, but this time we would see a lilac coloured flame, and that's because the hydrogen produced ignites. And the reason it ignites is because potassium is more reactive, much more reactive than sodium. So the exothermic, or the heat releasing nature of this reaction will produce, will set light to the potassium. Thank you very much.